Chapter 8, Part 1, Nomenclature and Classification of Alcohols. In the nomenclature of alcohols, alcohols are a priority group. This is the first group that we've seen that actually takes the priority over anything else that is on the molecule. This changes the suffix of the name to OL in the place of the E suffix we had been using for hydrocarbons. And then you use a locant to indicate the location of the alcohol. So let's take a look at these practice molecules below. Remember that anytime you're doing an IUPAC name, you always start with the same first question. What is my longest continuous chain? And you go from there. So in this first example, our longest continuous chain is 2 carbons. That gives us the prefix eth. And then the carbon-carbon bonds are all single bonds, so we use the infix an. And then we have an alcohol, so we will give the suffix ol. In this example, we do not need to use a locant because there are only 2 carbons, and whichever carbon has the alcohol would automatically be number 1 in order to number closest to the alcohol. Now let's look at the next one. We have 1, 2, 3 carbons, and I am choosing to number starting at the alcohol because it's the only interesting thing on the molecule. So this is going to be a derivative of propanol, and we're going to call this specifically 1-propanol to indicate that the alcohol is on carbon number 1. We could also call this propan-1-ol, which is sometimes a useful tool when you have a lot of different things on your molecule. Now let's contrast this to the one below. We can number from the left or the right because the alcohol is in the middle. This is also a 3-carbon alcohol. However, the alcohol is located on carbon number 2, so we call this 2-propanol. We could also call it propan-2-ol. On the next one, we are going to start numbering at carbon number 1. Notice we have a decoration on carbon number 2, so we'll have to reference that. So this is a derivative of 1-propanol again, but this time with that methyl group. So this is 2-methyl-1-propanol. Now, continuing on this page, there are some slightly more interesting examples that just have a few more things going on. So in our first example, our alcohol is closest to the right-hand side, so we're going to start numbering there. If you would like to, go ahead and pause and see if you can name everything on this page, and then you can watch the video and kind of speed through it to see if you got the answers correct. If you need a walkthrough, you can just watch the video at real time without speeding through. So we have 5 carbons. We have a decoration on the 4th carbon. It's the only decoration, so I'm going to go ahead and write that out. And I have 5 carbons and an alcohol on carbon number 2, so I'm going to go ahead and put 2. My prefix is pent. My infix is an, because that's all carbon-carbon single bonds, and then my suffix is ol. I could also call this 4-chloropentan-2-ol. On my next example, I have an alcohol group on a cyclohexane ring, so do not forget to include cyclo. And since the alcohol is automatically going to be carbon number 1, we do not have to indicate a number. In this next example, it's a small molecule, but there's something kind of tricky about it, and that's that the longest carbon chain can be a little hard to find. Some students might be tempted to do this, but you have to include the entire longest carbon chain. So any one of these carbons could be number 1, but you have to make sure that you continue numbering. So there's a methyl group on carbon number 2 and an alcohol on carbon number 2. So this is 2-methyl-2-propanol. In our next example, we have 2 alcohols on the same molecule. We can number from either direction. because it's symmetrical. So this molecule would be called 2,4-pentane diol. Now remember, when you have to put the di before either the infix or the suffix, you typically have to add in another letter. So we're going to have to add in an E, so it's pentane diol instead of pentanediol. And the 2,4 goes out here in front. You can also do pentane 2,4-diol. Notice that the di prefix goes directly before the thing that you have two of. It would not be correct to call this molecule 2,4-dipentanol because we do not have two pentane chains. We only have two alcohols on one pentane chain. On the next molecule, we have three substituents. Starting at the alcohol to give it a priority also happens to give us the lowest possible numbers if we continue in the clockwise direction. So we have two substituents other than the alcohol, so we need to provide their locants and alphabetize them. So bromo is going to come before ethyl. So this molecule is 2-bromo, 4-ethyl cyclohexanol. We still do not have to provide a number for the alcohol because it's automatically number 1. There's no other possible number it could be. Okay, and then we can also classify alcohols the same way that we've been classifying alkyl halides and carbons and hydrogens. We look at the carbon that the alcohol is attached to and then count the number of carbons directly bonded to that carbon. So this carbon that I've highlighted has a bond to one other carbon. That makes this a primary alcohol. In my next molecule, the alcohol is on a carbon that is attached to two other carbons. That makes this a secondary alcohol. In my last molecule, the carbon that has the alcohol on it is attached to 1, 2, 3 other carbons. That makes this a tertiary alcohol. Alcohols are polar molecules. The IMFs that are possible will include dipole-dipole interactions and also hydrogen bonding. Alcohols can hydrogen bond with themselves or with other polar molecules or molecules that contain hydrogens that are capable of H bonding. Because of their hydrogen bonding and their dipole-dipole forces, they will have higher boiling points than alkanes. The pKa values for alcohols tend to be between 16 and 18. So they're a little more basic than water, but typically not a lot more basic.